keynote presenters in the second plenary session. So now we move forward to the third keynote presenters from the second plenary session. To Professor Chai Yiyu, perhaps is he already in the Zoom? Okay, if Professor Chai Yiyu is already in Zoom, I may greet you. Okay, perhaps he's still on the way. So let me share this biography from Professor Chai Yiyu. So Professor Chai Yiyu is from Nanyang Technological University, and he is a Senate and tenured professor in this institution. And in NTU, he heads the computer-aided engineering lab and directs the strategic research program of VR and soft computing. He is also the deputy director of NTU Center of Augmented and Virtual Reality, and currently he is a leading team in NTU developing virtual and augmented reality technology to enhance learning. So he has over 20 years of experience doing R&D in virtual and augmented reality, simulation and serious games, artificial intelligence, and their applications in education. And his research has been supported by Singapore National Research Foundation, Temasek Trust-funded Singapore Millennium Foundation, Ministry of Education, and many other public-private sectors. He has co-invented 6 international patents and published 5 books and near 200 technical articles in SCI or SSCI journals and leading international conferences. So Professor Chai Yiyu will deliver the keynote presentation entitled Education, Innovation at NTU, and he will deliver the keynote presentation as a pre-recorded. So we may now start the keynote presentation now.
Hi, this is Professor Chai from Singapore. In the next 10-15 minutes, I'm going to share with you education innovation at NTU. For learning space innovations, this is a building called the Hive. We use this newer type of tutorial room for their student-centric, team-based, inquiry-based. Inside this Hive, you can see we have altogether 56 tutorial room. Only one is a traditional staircase kinds of lectures room. And most of the rooms are designed such a way students are grouped into 5 or 6, and the teacher becomes the so-called facilitator. And we have another similar building called the Arc, and the differences are students have more room, more space for their communication, social. Okay. And in campus, we built quite a number of fast restaurants. So students actually can have their study, discussion, and next to those fast food restaurants. Here is another area, it's a corridor area next to the car park. Our students now doing their self-learnings. This is another example in corridor next to my laboratory. We have this walk area turned into a learning space. Here is the student activity centers. They are indeed doing study hard and play hard. You see here is a new type of library in the same building, Hive. In this case, students actually can do their readings, and they can have a break. Okay, so this space is open to them 24 hours. Next, I'm going to share with you in so-called flipped classroom Hive. One of the Hive tutorial rooms turned to virtual and augmented reality technology enhanced learning space. Teacher is meditating and our students doing active learning in this space. Okay. Emphasize more hands-on presentation and discussions. And we have also utilizing such learning space as a maker room or maker space. Our students have formed their own interest group like robotics club and design club, okay, 3D printing club. Okay. In such maker space, our students doing their interdisciplinary, innovative, integrated, creative, and fun-filling kinds of learnings. Here is examples. This is part of my my subject called electronic system interfacings. I teach my students on the Fourier series, and they have about half semester to do a project based on the Fourier series. For instance, they use 3D printers, they use design software, they use kinds of Arduino part put together this interesting device. You see a small particle and suspended in the space without any support. This is something we call levitating object using sound wave. The last part, learning trail, I'm not going to detail here. Thus, I'm going to spend some time on the pedagogy innovations. In the classroom at the Hive, our student actually now is doing a lot of innovations, and particularly this benefit from the pedagogy we are interested. For instance, this flipped classroom actually is enabling this so-called flipped learnings. It's definitely blended learning and supporting inquiry-based learning as well as team-based kinds of learning. So in this flipped classroom or flipped learnings, that's based on the so-called the technology enhanced learning approach, which is implemented in NTU campus. And firstly, we do video recordings. For instance, you can see here I'm using the interactive whiteboard, and I use also another type called transparent blackboard, and I'm using also the blue screens. So these few methods, we have our physical lectures pre-recorded into the video format, and our students use the learning space, for instance, fast food restaurants, and our library, new type of library, our student activity centers, and those corridor area. So when they, based on their own interest and their own pace, they can do those video-based learning anytime, anywhere. Okay? And you can do it 10 times to watch video, or you can do it only one time, up to them. All right. Once this first round of video watching phase is over, student may have some idea or may have some questions, and then we arrange the flipped classroom kinds of meeting. Therefore, we can have a lot of discussions. And then let me now show you how we do this flipped learning in the virtual augmented reality technology enhanced learning space. This is a Hive. So now the student actually have 5 tables, each about 5 or 6 students on the table. So they use virtual augmented reality to simulate machines, training physics, same classroom, one assembly. This is part of the engineering course. Aerospace engineering student use augmented reality to visualize the engine structures and simulate various of functions, dismounting the structure, it's the hand, this is a cellular structure for science, biology science, and for humanities. Well, you see this flipped classroom and a flipped learning at the Hive and it is indeed a team-based. So we have the design. Each table have their own VR facility, and one of the students can wear the Oculus to have the control of the virtual space, like a machining or thinning. The rest of the students actually we use the 3D glasses to watch what's happening with the virtual machines and the workshop. Okay, they take turn to do this master control, and therefore each and everyone can actually have the experience to run the virtual reality system to learn turning and milling, assemblies and the disassembly. Here, for instance, the actual turning machine, we have about 5-6 turning machine in the school. And now we model exactly the same like the physical machine in our virtual workshop. Therefore, students can actually use this virtual reality technology to play and to learn the machining skill. The fun element part is important. I myself, I teach engineering, and also I used to teach biology, structure, molecular, cellular and molecular biology. For instance, we do a lot of gamification. This is a protein structure. It's one of the virus proteins, and we make it like roller coasters, and therefore students can play and at the same time learn the primary structure, sequential amino acid sequence structure, and secondary structure of these molecules, macromolecules. Okay. I have a little bit time to further detail the technology innovations. In the split classrooms, you can see we have hardware, we have most of the hardware are commodity kinds of product from market. Our job is to integrate them together, and it's supported with software we developed in-house, and we create a lot of contents, and we have our own pedagogy. So this way, this virtual augmented reality technology actually is enhancing such a learning through a kind of interactive learning space. So the artificial intelligence is also playing a role. Particularly, we have implemented those so-called in-process assessment, okay, and we are able to use the same kinds of virtual reality system, not only for assessment but also for debriefing. You see in the first picture, so student is interacting with the virtual molecular structures, and you can actually use the same models which converted into so-called STL format, and we can print it in 3Ds, and therefore students can visualize virtually and physically, right? For instance, we have science, technologies, engineering, art, and math. That's why I call STEAM. A number of topics we developed. For instance, biologies. We have anatomy, we have cellular, molecular structure, even virus structures. Okay. We have mathematics in quadratic surface. We have solid geometries. We have trigonometry. We have things like vectors. We have skew line, and of course in science we have also many different topics in physics like refractions, like electromagnetism. Okay, so there are quite substantial number of topics created for STEAM education. Example, how the virtual augmented reality technology used in math learning. For instance, here teaching the trigonometries, and here students are used virtual augmented reality technology we developed for electromagnetism. And this is the interactive learning of virtual cell. So all this work you mentioned about hardware, software, content, pedagogies, actually they create kinds of interactive learning environment. All these things rely on some innovative research. So my team, particularly many of my PhD students over the year, they focus on fidelity modeling and simulation. They do realistic stereographic visualizations, some of them doing real-time interactions, and many of the students actually they are interested in natural user interface. And of course, we have students spend their time developing series game. Okay, and for this type of research topic, actually they rely on some fundamental or enabling technology. Therefore, our students often they look into mathematics, optimization, artificial intelligence, high performance computing, data analytics, robotics, sensor, mechatronics to develop those solution approach. Okay, and we have published quite a number of books by Springer. For instance, the 3D immersive and interactive learnings, VR, simulation, series game. Before I finish my presentation, I would like to invite colleagues here to join us next year in Singapore. I myself is General Chair for this IEEE International Symposium on Mixed and Augmented Realities.
Thank you very much to Professor Yiyu for presenting the keynote presentation.